So we were working on worksheet 3. We completed problems 1 through number 3. So let's look at number 4 from the worksheet. I think you guys should be able to do number 4 and 5 with your lab activities. So let's look at number 4. I didn't bring it today, so let me go and see in my office if I have more. I'll be right back. You need one? Okay. Anyone else need? Okay, so let's look at number 4. So on number 4, you're given two vectors. Let's call those vectors A and B. So A is 16 meters at 45 degrees. So if I want to represent this on a graph, I can represent this on the quadrant. So 45 degrees is like that. So that's vector A. And we have another vector, vector B, and it is 25 meter at 30 degrees. Okay, so I can represent that in this graph. So let's see, 25, 30. It's not exactly that. Okay, so that's B. So the question is asking, write each vector in terms of unit vectors. Unit vectors is in this form. Okay, so if you have vector A, its unit vector is x component along x-axis. That I hat means x-axis. This is called unit vector. Vector showing which way this ax is pointing, and then y component, which is pointing in y direction. Okay, that's unit vector. So we want to write these vectors in this form. So for that, we need to find ax and bx. So ax is 16 cosine 45 degrees. Okay, bx is 25 cosine 30 degrees, and then y component of A is 16 sine 45, and y component of B is 25 sine 30 degrees. Okay, so x and y components. So you can do on your own. Don't just copy from here. Try yourself and then check your answer with me. Okay, so let's see what value you get for this one. So 16 cosine 45. That comes out to be, okay, I don't have the answer here. You guys can tell me the answer. 11.3 meters. How about this one? 25 cosine 30. This one also should be 11.3. What's that? Okay. And then bx and by. .7 meters, and then by is, I think, 12.5. Let's see, someone made a comment here. Let's see, what's that? Oh yeah, so we are working on worksheet 3. This is question 4a, that's right. Okay, so what's bx you said? Okay, 21.7, and by is 12.5. Okay, so we got all the components. Now we can write a in terms of component. So ax is 11.3 meters. This is along x direction, so I hat. Ay is 11.13 meters. This is along y direction, so j hat. And then b is 21.7 meters. That's along x direction. And then by is 12.5 meters. That's along y direction, so that's j. Okay, so that's part A. Now part B is, what is the sum of these two vectors? Write your answer in the vector, unit vector format, and magnitude and angle format. So to add these, or to get the resultant in terms of unit vectors, we can add I hat term with I hat term and j hat term with j hat term. Okay. So we want to do A plus B. 11.3 and 21.7. That is 33 meter I hat, plus 11.3 and 12.5 is 23.8. 23.8 meters, and that's along j hat. Okay, so that's the sum of two vectors. Now we can also write this in the magnitude and angle form. So for that, to write in magnitude and angle form, so it is denoted by that. So this means its magnitude. Magnitude is given by x component squared plus y component squared. Okay. So this is the resultant vector. So we want to find r, resultant r. R is rx squared plus ry squared. Okay, which is what we got here. So let's do the math. I got 40.7. Is that what you guys got? 40.7? Okay, 40.7 meters. And then we also need to find the angle. So angle is tan inverse y component over x component. So tan inverse y component is 23.8, x component is 33, and you do the math. That gives me 35.8. Okay, so you can write either the resultant in this form or as magnitude and angle. Okay. So let's look at number 5.
I mean, that's usually how I would eat it.
A bird flies 100 meters due east from a tree, then 200 meters northwest, that is 45 degrees north of west. What is the bird's net displacement? Okay. So our origin is the tree. Okay, so that's our origin. Bird flies 100 meters to the east. So let's use different color. So that's the first displacement, which is 100 meters. Okay, and then from there it flies 200 meters northwest, 45 degrees north of west. So it flies to the west like that at 45 degrees to the west. And it flies 200 meters. Okay. So this length is twice as much as this length. So what's the net displacement? So we have two vectors, vector A and vector B. So we know the vector addition method. If you have two vectors, how do you add these two vectors? We learned that in lab last time. So take the first vector, okay, and then connect the head of the first vector to the tail of the second vector without changing the orientation. If it is in this orientation, then do not change that orientation. Just transfer this one to the head here. And then connect the tail of the first one to the head of the second one. Oops. And this gives the sum of the two vectors. Okay. So same thing we can do here. So we can connect the tail of the first one to the head of that, and that will give us the sum. So that's the graphical method. But here we don't want to do the graphical method. We just want to use the analytical method. This is a component method or analytical method. So how we do that? So for that, so we need to first write. We need to get the components. So AX is, this is A. What's the X component of that? It's 100 meters. Cosine. What's the angle of this? 0, yeah. And then AY is 100 meters. Sine 0. So this is for the first vector, this red one. And for the second vector, this one, this is 200 meters, not degree. Bx is 200 meters cosine so there are two ways to deal with this one. Okay, Either you choose this angle, usually we measure the angle from the in the counterclockwise direction. Either you choose this angle, use this angle, or if its x-axis is pointing to the left, then you put minus sign in front. Okay, you choose this angle. What I mean is, so you have this vector. Its y component is in the positive direction. Okay, so that's the y component. So this is call this b. So by is positive, but bx is pointing this way. If it is pointing to the left, you can just choose this angle made by this vector with the x-axis. Okay, and then you choose the negative sign. Okay, so for the vector pointing to the left, use negative sign here. So in this case, also, its y-axis is x component is pointing to the left. Okay, if you if you project this vector on x-axis, that would be its x component, which is pointing to the left. So we have minus sign here, 45 degrees, and by is 200 meter sine 45 degrees. I didn't use minus sign here because its y component is up. Okay. So let's find the values for each of these components. So I will let you guys calculate that and tell me the answer. Okay. So 100 meters. This one should be 0 because sine of 0 is 0. How about this one? Is that 141? Not 141. Okay, 141.4 negative meters, and this one is also 141, right? 0.4 meters. Okay, and now to add the vector, we add the components first. So we want to get Rx, resultant of the x components, which is Ax plus Bx. So 100 meters plus minus 141.4 meters. So that will give us negative 41.4 meters. And then Ry is Ay plus By. Ay is 0 plus By is 141.4 meters. So that's 141.4 meters. Okay. So our vector, the sum of the two vectors, is negative 41.4 meters along I direction plus 141.4 meter along j direction. You can write in this way, or alternatively, you can also write in magnitude form. So to express in magnitude form, we can first find the resultant using Pythagoras theorem. So Rx squared plus Ry squared. Rx is negative 41.4 squared plus Ry is 141.4 squared. If you do the calculation, I should give you 147 meters. And then we also need to find theta, tan inverse Ry, which is 141.4 meters, and Rx, which is negative 41.4 meters. That gives us negative 74 degrees. Okay, so R is 147 meters at negative 74 degrees. So when you know only the magnitude, you don't put the arrow here. Okay, I don't have arrow here because I'm finding the magnitude. And here I know both the magnitude and angle or direction. That's why I'm putting the arrow here. Now we have a complete vector. Okay, so that's worksheet 3. Next, let's look at worksheet 4. Those who are on Zoom, you can download worksheet 4 from Blackboard. It's in week 3 folder. Here is worksheet 4. Okay, let's look at number 1 on worksheet 4. It should be pretty straightforward after doing all these vector addition. So let me copy and paste the question. Okay, so on the first one, it's asking you to draw x and y components of the first vector or of the given vector. So pretty straightforward. You project the vector on x and y direction or x and y axis, and that will be your x component. So project this on x axis. So this thing, you don't need to write the arrow here. Okay, just show that this is ax, and then you can use either this one or this one as ay. Okay. Likewise for this one, project this on x-axis. So this would be x component, and then project this on y-axis. So this would be y component. Or you can also say this is your y component. Okay, I cannot write straight. On the third one, you don't have y component, it's all x component. So this itself is x component. Number 2, determine the numerical values of x and y components of each vector. So we already did that. So there are 2 ways to do this again. So here you can choose this angle. First, let's see where our x and y components are. So our x component is that, and y component is that or that. Okay. So you can either use a cosine 130 degrees, okay, this angle in counterclockwise direction, or you can also use this one. Okay, if you use this one, this would be in clockwise direction. So this would be 180 minus 130 would be 650 degrees, or you can say a. If you use this one, then you need to put minus sign here because this is in the negative quadrant, okay, negative side. So negative a cosine 50 degrees. Both should give you the same answer. For y component, you can use a sine 130 or a cosine or sorry, a sine 50. Now I don't put negative sign here because you see y component is on the positive quadrant. Okay, it's going up. Up is positive. If it is left, it's negative. So get the answer. Okay, you should get. Yeah, you can. That's what I'm asking. So for the final calculation, you need to plug in this value 5. So this is just showing how to do. Okay, so this a would be 5. That would be 5. So all these a's would be 5. I want you guys to do the calculation. Like, let me show you this one, okay, with the answer, and then I think you can do the other ones. So let's look at x component. So project this on x-axis. So that's our x component, and project this on y axis. That's our y component. Okay. Or instead of writing ax and ay, here we are writing cx and cy's because the vector is c. So let me write here c, okay, just to use the same letter. So cx, we can choose this angle. So c, okay, vector, the length of the vector times, for x component we use cosine 45 degrees. And I don't use minus sign here because this x component is on the positive side. Okay, when it's on positive side, you choose positive here. But for cy, I'm going to use negative sign because this is on the bottom side or below the x-axis. Okay, so I put minus sign here. So that's sine 45 degrees. So c is 5 cosine 45 degrees, which will give us 3.54, about that. And this one is 5 sine 45, okay, negative. So that will also give us same number but with negative sign, 3.54. Okay, you can do the second one also, similar kind of thing. For second one, you need to put negative sign for both because x-axis, or I mean x component is also on the negative side and y component is also on negative side. Okay, both x and y component are in the negative quadrant. So again, minus and minus sign. So that's number 2. Let's look at number 3. Okay, so here we need to find the magnitude of the vectors. We are given the components, and from the components we need to find the magnitude. It's pretty straightforward. Okay, once you have magnitude, you can use the Pythagoras Theorem. So resultant is rx squared plus ry squared. Okay, this applies to all these figures. So just do the square root of 3 squared plus negative 2 squared. So whenever you have a negative sign, do not forget to put the parenthesis, otherwise you will not get right answer. Okay? So that will give us 3.61. Okay, likewise here, it's negative 2 squared plus 2 squared. Okay. that is 2.83. And it's also asking you to draw and label the vector, okay? Not just the magnitude, we also need to draw. So let me show you how we draw that. We already did this in lab. So x, we go 3 units to the right. So we go 1, 2, 3 units to the right. And then y, we go 2 units down. So 1, 2 units down. So our vector would be that, okay? Here, we go 2 units to the left, so negative means going to the left, 1, 2 units to the left, and then 2 units up, okay? So 1, 2 units up. So that's where the vectors end. Okay, that's the vector. That's B, that's A, and then here we go 0 units to the right or left, okay? Just add 0, and then 2 units down, so 1, 2 units down. So that's our vector. So when you write vector, you also need to use the arrow, okay? So let's look at number 4. Write the vector in component form. Pretty straightforward. Just look at the picture, see how many units you have. So in component form means you need to write in this form, okay? A as ax I hat plus b, a y j hat, okay? So what's the x component here? 1, 2, 3 is the x component along x direction. And then what's the y component here? We have 1 units up, okay? Plus 1, you don't need to write 1, you can just write j hat. Here, how many units we have for x component? We have 1 unit, but it's in the negative direction, so minus 1 in the x direction. And how many units we have for y? So we have 1, 2, okay? 2 down, 1 left. So down is negative j hat. Here we have 3 units to the left. So negative 3, left means negative 3 along x-axis, plus no up or down. So 0 j, that means you can just write nothing, or you can write 0 j. Okay, let's look at number 5. 5 is pretty straightforward. So we will be using these 3 vectors and add them to get the resultant. So we want to find the resultant of these 3 vectors. Let's denote that by letter D. D is A plus B plus C, okay? Adding. So A is 3i hat plus j hat, and then B is minus I hat minus 2j hat plus C is negative 3i hat. Now put all the I hats on one side and all the j hats on the other side, okay? So 3i hat minus I hat minus 3i hat plus j hat negative 2j hat. Okay. So what would be the sum of these 3? All have I hat. So there are 3 I hats here, negative 1 I hat here, and negative 3 I hat here. Negative 3 I hat and positive 3 I hat cancel. So we have negative I hat left, plus j hat and negative 2 j hat. What's the answer? What's the value? Negative j hat, right? So our vector is negative I hat, negative j hat. If I represent this on this picture, I have one unit of I hat along negative direction. So along x direction, it goes up to this point, and then along y direction, it goes up to there. Okay, so that's my resultant vector, or in this case, it's D. Okay. Let's look at number 6. So for each vector given below, draw the vector on the axis provided. Draw and level the angle theta to describe the direction of the vector, and find the magnitude and angle of the vector. So that's, again, pretty straightforward. Just need to see the x component and y component, and then based on that, you need to draw the vector. Okay, so we have 2 units to the right, and then 2 units up, 2 units up, and then that's our vector, and that's our angle. Okay. Now magnitude, how do you find the magnitude? Use this Pythagoras theorem. Okay. So whenever you are asked to find the magnitude, add or square the x component, square the y component, add them, and then take the square root. Okay? That gives you the magnitude. So we have 2 squared plus 2 squared, square root of that. That is 2.83. And then for angle, use tan inverse of y component. Y component is 2, and x component, that should give you 45 degrees. I think you guys can do the other ones also, okay? Pretty straightforward. I will let you guys do the other ones. So let's look at number 7. So for number 7, you are given the graphical picture. Number 7 and 8 are based on the given graph. Okay. Add the vectors geometrically. How do we add the 2 vectors geometrically? Head to tail method. There's another method also, which is called parallelogram method. Okay, you can use either head to tail method or parallelogram method. I'll show you both. So for head to tail, choose the first vector. That's our first vector, and our second vector is that. So transfer the tail of this to the head of the first vector without changing its orientation. Just shift this up until the tail touches the head. Okay. So then it would look like that. Okay. It's not exactly that, but it should be parallel. Okay. I cannot draw a very straight line here. It should be of same length and same orientation, only transferred from down here to up here. Okay, so that would be our B, and then the sum of A and B would be connect the tail of the first one to the head of the second one. So now I need to draw a straight line. Okay, it didn't end to the tail of the first one. Come on, it's so hard. Okay, you guys can draw the straight line. Okay, so this is A plus B. Now you need to figure out the x and y component of this resultant vector. Let's call this R. So find Rx and Ry. So count how many divisions you have along x-axis and how many you have along y-axis. So for x-axis, it looks like one division and a little bit more than one division, more than 1.5. So 1.5, 1.6, around 1.6 maybe. So I will just estimate it as 1.6. Okay, so 1 and then up to here 1.6, and then Ry. So go up 1, 2, 3, 4, 5, 5 point. Actually, it goes all the way to here. Okay? So it crosses the sixth line, the sixth mark. I didn't draw it quite right. If you use the ruler, you would get a better value, but since I'm doing this roughly, so it crosses this one. So it's about 6.1. Okay, 6.1. It crosses the sixth vertical mark, and then we want to find the resultant. Write the resultant vector in terms of unit vectors. So resultant R in terms of unit vector would be 1.6 I hat plus 6.1 j hat. Okay, which is in terms of unit vectors. Verify the above answer by writing the vector A and B in terms of unit vectors and adding the vectors algebraically. So write in terms of components. So A can be written as, let's see how many divisions we have, 1, 2, 2.8, something like that. So 2.8, just looking at A. Okay, so A has 2.8 divisions to the left. Because it's to the left, so I need minus sign here. So that's along x direction. And how many divisions it has in the upward direction? So 1, 2, 3, 4, about 4.8. Okay, so plus 4.8 along y direction. Likewise, B. Now let's look at this one. 1, 2, 3, 4, 4.4, let's say. Okay, 4.4 I hat, and up is 1. Make estimation. Okay, there's no like exact division here, so we need to make the estimation. It's about 1 and let's say 1.3. Okay, 1.3 j hat, and then you add these two. Okay, so resultant is the addition of these two. So when you do that, what you get 1.6 I hat plus adding these two, you get 6.1 j hat, which is exactly same as the one you got here. Okay, so using both the methods, you get the same answer. so let's look at number 9. So define vector A, which is 5 units at 30 degrees. Determine the components ax, ay in 3 coordinate systems shown below. Show your work below in the figure. So we are using the axis in different orientation. The vector is same. You see the vector is pointing to the northeast, but we are tilting the axis in different ways. So how do we do this one? Okay, so the first one is straightforward. Okay, just to use 5 magnitude. For x component, we use cosine 30 degrees. Y component is magnitude times sine 30 degrees. Okay, so the value of this one 433. The value of this one is 2.50. Now this one, so you need to look at this axis, okay, tilted axis, and we always measure the angle with respect to x axis. That's something you need to keep in mind. So when you are finding the x component, you need to first write the magnitude and then cosine, and then angle is with respect to this x axis. So this angle, which is what, 30 plus 30 is 60, right? 60 degrees. And then the other one is just using the sine, okay? Sine 60 degrees. How about in this one? So this is our vector. We need to measure with respect to x-axis. So this would be our angle. What's the angle? I'll let you guys figure that out. Do a little bit of geometry and find out that angle. Tell me what that angle would be. $15, that's right. That's right. So you can show that this whole thing is 45 degrees. Okay, whole thing is 45 degrees, and then this would be 45 minus 30 degrees, which is 15 degrees. So ax is 5 cosine 15 degrees. Should I use negative or positive here? Is the component pointing to the left or to the right? The component of this one, x component, is this one. Okay. Why is it negative? That's the this one. It's positive. It's pointing to the right, right? Yeah. So that's positive. How about y component? Is it pointing to the down or up? Negative, right? So 5 sine 15 degrees. Okay. Okay. So that's all for worksheet 4. Please complete that and then submit that on Gradescope. And quiz is due today, so it's already on Blackboard. Please take the quiz. And that's all for today. If you guys have any question, you can ask me questions. Otherwise, have a great weekend.